Yeah, so let's see the first question. So this question is directly from HATE book, okay, HAYT, HATE. So this is coming from that book only, but their answer is given wrong actually. They have given the answer to be wrong, okay. There is no uh, there is no doubt about that, the answer is wrong, but it happens with standard books. So let's solve it correctly now. So first what they are saying is that incident angle is given. You need to find the fraction of incident power that is reflected and transmitted. So basically you need to find PR and PT for P polarization. So let's first solve it for P polarization. P polarization means, how would you remember? Parallel polarization. Two P are there. So P polarization means parallel polarization. So P polarization. For finding the like power which is reflected or transmitted, what we need to do? We need to find reflection coefficient, right? Reflection coefficient is very important. So let's find it out. So what is my reflection coefficient? What is the formula? Parallel. Parallel means both lines are not cutting each other. So neta and theta of same. So neta 2 cos theta t minus neta 1 cos theta I divided by neta 2 cos theta t plus neta 1 cos theta I. Now you see one thing, they have given the refractive index. They did not give intrinsic impedance. This is refractive index. They have given refractive index. This is not intrinsic impedance. So n I am, yeah, this feels like neta only. So n I am showing like this. This is your refractive index. So when we wrote down Snell's law, what did we write? In place of n, we wrote beta there, right? When we were writing Snell's law, in place of refractive index, we wrote beta there. And our beta is proportional to under root mu epsilon, right? What I am saying, this is not equal, I am just telling the proportional sign. That our refractive index neta, our refractive index n was proportional to beta. And beta is proportional to under root mu epsilon. They must have given it is a non-magnetic material, but you need to consider it is a non-magnetic material. So from here what I get to know that my beta is proportional to under root epsilon only, and that is proportional to refractive index. This is our refractive index. So n is proportional to epsilon, under root epsilon. But if you remember the neta formula, neta, this is my intrinsic impedance. This is my intrinsic impedance. This is my intrinsic impedance. So what is the formula for that? Under root mu by epsilon, right? So this neta is inversely proportional of under root E. So from here what you are getting, that this your n is inversely proportional of neta. Is that clear to you or not? Are you getting this point? What I am doing here? I just need to find the relation of this refractive index they have given. So I just need to find that what would be the relation between refractive index and the intrinsic impedance, because here I need to put intrinsic impedance. This is neta, this is not n. This guy is neta, not Nita Ambani. This is neta. What I am gonna write? यार मेरे पे कॉपीराइट स्ट्राइक तो नहीं मार देंगे, मैंने उनका नाम ले लिया. इंट्रिंसिक इम्पिडेंस. नो वरीज, हार्दिक पांड्या विल सेव मी. मैं बड़े लेम जोक्स मारता हूँ यार, बड़े लेम जोक्स मारता हूँ, तभी मेरे कॉलेज में इतने सारे दोस्त थे. So this is your intrinsic impedance, right? So your intrinsic impedance is inversely proportional to your refractive index. So what I can do is that if I take n2 outward, if I take neta 2 out from it, what I will get? Cos theta t minus n1 by n2. Again I am saying n1, it is neta 1 by neta 2. It is neta 1 by neta 2 divided by cos theta t plus neta 1 by neta 2 cos theta I. Now can you tell me the value of neta 1 by neta 2? What I am asking, what will be the value of neta 1 by neta 2? Neta 1 by neta 2 will be equals to n2 by n1. Do you agree to this point? Neta 1 by neta 2 will be n2 by n1. Why is that so? Because neta is neta is inversely proportional of 1 by n, or you can say proportional of 1 by n, right? So they have inverse proportion. They have inverse proportion relation. So neta 1 by neta 2 is equals to n2 by n1. And what is the value of n2 given? N2 is given as 1.45. And what is the n1 for free space? That is 1 only. So this value neta 1 by neta 2 is 1.45. Is that clear to you or not? How did I get to here? I started with the Snell's law. I know that my refractive index was replaced with beta. That means my refractive index has to be proportional to under root epsilon. But my intrinsic impedance is inversely proportional to under root epsilon. That means refractive index and intrinsic impedance both are inversely proportional to each other. So here I need ratio only, because if I take neta 2 outward, then neta 2 will get cancelled. Here you will be left with neta 1 by neta 2 and neta 1 by neta 2. So what will be the ratio of neta 1 by neta 2? That would be equals to n2 by n1. Neta 1 by neta 2 would be equals to n2 by n1. And n2 I know, n1 I know. So there you go. Now what else I know? Now theta I know. So this is something that I have got now, that my neta 1 by neta 2 is 1.45. Along with that I know theta I. Theta I is 30 degree. So can I apply Snell's law now? Snell's law. So what that would be? It starts with beta, or you can start with refractive index as well. That n1 sin theta I is equals to n2 sin theta t. What is n here? N here is refractive index. Spelling देख लेता हूँ. Refractive index. This is your refractive index. Is that clear to you? Okay. So this is 1 only, and this is sin 30 is equals to n2 is 1.45 sin theta t. Okay. Have I solved it anywhere? So from here sin theta t I am getting as 0.344. This is the value of sin theta t we are getting. Now if I write down this formula, that is our gamma parallel E. Gamma parallel E. So that would be cos theta t. So cos theta t I need to get from here, cos theta t. So what I can do, 0.344 is there. So from here I can get cos theta t. So let me take the calculator. Now everything is based on formula only. You can apply the formula and get the results. Cos theta t is coming out to be 0.93, 0.938 minus n1 neta 1 by neta 2 is equals to 1.45 into cos theta I. Cos theta is sin 30. No, sorry, cos 30. So cos 30 is under root 3 by 2. And then 0.938 plus 1.45 under root 3 by 2. Okay. So let's see the answer now. 3 under root by 2 into 1.45, 1.255, 0.938 minus 1.256 divided by 0.938 plus 1.256 minus 0.938 divided by 0.938 plus 1.256. Okay, so this is what we are getting, minus 0.145. What we need to find? We need to find the power that is reflected and transmitted. So what will be the reflected power? Reflected power will be simply reflected by incident power. What will be the ratio of PR by PI? That would be equals to gamma square, right? So square of it, 0.021. And what will be that transmitted by PI? So that would be minus 1, that is 0.97 into cos theta I, that is cos 30 degree, divided by cos theta t, right? This will be the answer. 0.97. 0.97, how it is coming? 1 minus this guy, 1 minus 0.021. That would be 0.97 only. right? Then into cos theta I divided by cos theta t. So cos theta t I don't know, cos theta t I am writing down from here only. Okay, cos theta t is this 0.938, right? Cos theta t is 0.938. 0.938. So divided by 0.938 into cos 30, 3 under root by 2. So 0.9, 0.90. So these are the two answers, right? So a lot of formula was there, but these kind of questions are actually asked in the examination. Whenever the question is coming from oblique incidence, that will take some time. There will be calculation as well. So certainly these kind of questions are asked where calculations are involved. So we have solved it for P polarization. Can you solve it on your own for S polarization? You can solve it, but I need to solve it because this is a recorded video. So for recorded video, I have to solve it on my own as well. But you should try solving it on your own. You know everything. You know the relation between neta, beta, and n as well. Neta, beta, n. N is the refractive index here. Okay, n is not your intrinsic impedance. So that confusion should not be there. Okay, so I hope you must have understood a lot of things from this question. Now let's add a page and solve the remaining part of this particular problem. Now what we need to do, we need to consider S polarization. Okay, so for S polarization means perpendicular polarization. What is the formula? Neta 2 cos theta I minus neta 1 cos theta t divided by neta 2 cos theta I plus neta 1 cos theta t. 0.938 minus, oh sorry, this is cos theta I, sorry, cos theta I. What is the value of cos theta I? That is under root 3 by 2. Cos theta I is under root 3 by 2 minus, what is neta 1 by neta 2? That is 1.45. Neta 1 by neta 2. What I am doing, neta 2 I am taking outward. So neta 1 by neta 2 is 1.45 into what is cos theta t? Cos theta t is 0.938 divided by under root 3 by 2 plus 1.45 into 0.938. What we are getting? 1.45 into 0.938 minus 0.866. So that is coming out to be minus 0.4941 divided by 1.45 into 0.938 plus 3 under root by 2. 2.226. Okay, yeah, then take the reciprocal into 0.4941, 0.22. What we are getting? 0.22. Now if I need to ask reflected by incident, so what that would be? 0.221 it is. So if I need to find that thing, then what will be the answer? Just take the square of it, 0.049. And if I need to find that transmitted by incident, what that would be? 1 minus gamma e square, then here cos theta I divided by cos theta t. So what is my cos theta I? Cos theta I is under root 3 by 2 and cos theta t is 0.938. So let's see it, what we are getting. Minus 1 into 0.866 divided by 0.938. 0.877. Is that correct? Yeah, 0.876 we are getting. So 0.876. So these are the correct answer. Yeah, it involves calculation. Involves calculation. But if you just know this thing, which is a very important thing which we derived from this expression, but if you know this thing, then it will be solved very easily and very quickly as well. if you know only this formula. Not formula, if you know this relation that your refractive index and intrinsic impedance are inversely proportional of each other. Is that clear? Okay. Let's get to the next question. The dielectric constant of a pure water is given. Determine the Brewster angle for polarization and the corresponding angle of transmission. A plane wave with perpendicular polarization is incident from air from water surface at this. Find the reflection and transmission coefficient. Okay, let's start. So first we need to find Brewster angle. So here they did not mention about mu r. So mu r by default I will take 1. So what I need to find? I need to find Brewster angle for parallel polarization. So what will be the formula? That would be equals to tan inverse under root 80 divided by under root 1. So that would be equals to, just a second, 80 under root tan inverse 83 point, ये क्या हो रहा है, 83.62 आ रहा है मेरा, यहाँ पे 81 डिग्री लिख रखा है मैंने, क्या बात है, 83.62 we are getting. Why I have written 80 degree, 81 degree here? I must have directly copied it from the Hate book only. This is also from Hate only, I guess, as far as I remember. As far as I remember, I am not sure, but as far as I remember, this is from Hate only. But yeah, answer is 83.62, not 81 degree. Okay, let me see if there is some glitch or anything. No, it is 83.62 degree. So let's remove it. 83.62 degree. Now corresponding angle of transmission we need to find. So what we know? We know that beta 1, Snell's law I am applying. This is the first one. Second I am applying Snell's law. Beta 1 sin theta I is equals to beta 2 sin theta t. So this angle we need to find. Angle of incidence is this guy, because it is incident on Brewster angle. So theta is equals to, here theta I is equals to theta b parallel only. So beta 1, this is proportional to under root epsilon r1, and under root epsilon r1 is equals to 1 only. Sin 83.62 degree is equals to under root 80 sin theta t. Okay, so theta t I will be get from here. So what I need to do, I need to take sine of it, then divided by under root 80, then I need to take sine inverse. So 6.38, yes, this is correct, 6.38 degree. So this is the second one, this is the first one. Only formula based question, okay, only formula based. Now third one, what they are asking? A plane wave with perpendicular polarization is incident from air on water surface at this particular angle. Basically, in case of perpendicular polarization, this is your incident angle. Then they are asking the reflection and transmission coefficient for perpendicular polarization. So for perpendicular polarization, what is our formula? Perpendicular, the two lines are cutting, neta of this and then theta of this. I plus neta 1 cos theta t. Okay, so now neta is inversely proportional of under root epsilon r, that I know, right? So can I write it down? What is my cos theta I? Cos 83.62 degree, cos 83.62 degree minus, what will be the angle of transmission? This will be the angle of transmission, no? If you apply the Snell's law will be same for parallel polarization and perpendicular polarization. It will be same. So here if you apply Snell's law, what you are gonna write? Beta 1 sin theta I, that is same only. Beta 2 sin theta t you will get, that is 6.38 degree. So Snell's law is same. There is no doubt about that. So cos theta I divided by under root epsilon r2. Why is that so? Because what I am doing is that, or forget about under root epsilon r2, what you can do, you can again take neta 2 outward. If you again take neta 2 outward, what you will be left with? Neta 1 by neta 2. Neta 1 by neta 2 would be equals to, will be equals to under root epsilon r2 divided by under root epsilon r1. Why is that so? Because neta is inversely proportional of under root epsilon r, right? So neta 1 by neta 2 is equals to under root epsilon r2 divided by under root epsilon r1. So what is under root epsilon r2? Under root 80. So that is under root 80. Okay. So neta 1 by neta 2 is under root 80 into cos theta t. What is cos theta t? Theta t is 6.38 degree. 6.38 degree. Here plus would come cos 6.38 degree. Is that clear to you? Yes. So let's find out the answer. So cos of this into 80 under root 8.88 minus 83.62 cos, that is 0.11 minus 8.88 minus 8.88 and divided by 0.11 plus 8.88. So what I will be left with? Minus 8.76 divided by 8.99. So minus 0.97 minus 0.97. Yeah. So approximately you are getting minus 0.97. I know calculation are there, but it is what it is. In the examination also you need to do these kind of calculation if question is coming from oblique incidence. Okay, believe me. That's why I am taking these kind of questions. And if you need to find the transmission coefficient, so what is the formula? In case of perpendicular, E is happy. So this will be the formula. So simply if you add 1, that answer will be your final answer. Okay, so 0.024. 0.024 क्या हो गया इसको? 0.967. Yeah, like it depends on the calculation, right? Basically what happens is that like here we have taken approximation, here also we have taken approximation. So after the approximation we are getting this answer, right? So let's write it down 0.03. That is near to our approximation. What I am saying is that here by calculating this value we took some approximation. By calculating this value also there is some approximation. Then this answer also came after approximation. Then this is also after coming after approximation. So a lot of approximation are there. Then in points there is some issue. Actual answer is this only. In the book this was given. That's why I wrote it directly. So in the book this was given, but if we take near approximate, 0.03 would be correct for us. Okay. Yeah. Okay. Then this was an easy question only. We will solve this question, but let me take a break again because I have some work to do as well. So you try it on your own. This is a very good question, like it will take 30 minutes of time I guess to explain it. So you try it on your own, then we will start solving this question. So you know everything. Polarization you know, angle of incidence you can find, then you can find reflected field as well, you can find transmitted field as well, everything you can find. Just draw the diagram. What I am saying, draw the diagram first. If you draw the diagram, it will be easy for you. If you do not draw the diagram and if you just keep on applying formula, it will not work. Is that clear to you? Okay. So let's start, but let's take some break in between. Yeah, so let's see this question. This question is from Sadiku and I hope you must have tried it on your own now. If you are not able to solve, then also it is okay because these questions will take time, like it will take some practice. So that is fine if you are not able to solve, no need to be demotivated. So let's see how would we solve it. So first we need to draw the diagram. So do you know how to draw the diagram? Yes. First I will find the wave propagation vector. What is that? 4ax cap plus 3az cap. So from here you can tell me the direction of wave propagation. The direction of wave propagation would be 4ax cap plus 3az cap divided by 5. So which plane I will make? I will make xz plane. And how will I decide now that which will come on horizontal and which will come on vertical? So that I will decide using the boundary. So what is my boundary? Boundary is z equals to 0. Your boundary is z equals to 0. So that means z axis should come on horizontal. So this is how now I will make my plane. And Z axis is coming on horizontal. Well, let's make it on the next page because it will take, it should be a bit bigger. Zx. Now how my wave is traveling? 4 in x, x is upward actually, 4 in x and 3 in z. So wave would be traveling something like this. So wave is striking like this. And which is my boundary plane? My boundary plane is this xy plane, right? I hope you are comfortable with this diagram. Xy plane is the boundary plane. This is how the wave is coming. So how it will be reflected back? It will be reflected back in this manner. First we need to find this incidence angle. Okay. So in the previous video I asked you to find this angle using dot product. So using dot product also you can find. How will you find? This is your EK cap, right? If you need to find the incident angle, then how would you find? You would say that the sir cos theta I is equals to 4 AX cap plus 3 AZ cap divided by 5 dot product with AZ cap, because what is the unit vector here? This is the unit vector. You are going from Z less than 0 to Z greater than 0. So unit vector is AZ cap. So dot AZ cap you would do. So dot AZ cap you would do. So from here theta I would come cos inverse 3 by 5 and that would be 53.13 degree. Okay. Or how you could have solved it? Look, this wave is going, this is your incident wave. What do I know is that it is going 3 here, like 3 in z direction and 4 in y direction and 4 in y direction. Can I shift this vector here? Yes. What I am doing, it was going 4 in y direction, 4 in x direction, so I just shifted this vector here. So this is 4 and this is 3. What this angle would be? If this is theta I, so certainly this will also be theta I. You can see two parallel lines are there, it is cut by this line and then these two angles will be equal. So if this is theta I, this will also be theta I. So what will be your tan theta I? Tan theta I from here you can see is 4 by 3. So theta I would be tan inverse 4 by 3. It would be the same only. Okay. Answer would be same. Theta I would be 53.13. So better than dot product, using only our EM wave only, using the direction of EM wave propagation, we can find the value of theta I without even using the dot product. So you can do whatever you are comfortable with. Okay. So two method I have told you how to find the value of theta I. Now let's see where is my electric field. My electric field is in y direction. So electric field is in this direction. So my incident electric field is in y direction. Is that clear to you? So this is my incident electric field. So which kind of polarization is that? Perpendicular polarization. Right? This is our perpendicular polarization. Okay. Incident angle we have. Let's find out the transmission angle. Basically, reflection angle will be equals to incident angle only, and that would be equals to 53.13 degree. But let's find out the transmission angle. How will we find out? Using Snell's law. What Snell's law would say? That beta 1 sin theta I is equals to beta 2 sin theta r. So beta 1, what did I say? It could be written as root epsilon r1, because beta is omega under root mu epsilon. So omega would be same, just epsilon would be coming, and by default you will need to take non-magnetic material. So under root epsilon r1, this is traveling in air only, so under root epsilon r1 would be 1 only. Here sin theta I would be equals to beta 2. Beta 2 is under root 2.5. Under root 2.5 sin theta r. Okay. We need to find the value of, not sin theta r, sorry, it should be written as sin theta t. Transmission angle we are talking about, not sin theta r. Transmission angle. Beta 1 sin theta I is equals to beta 2 sin theta t. So sin theta I, value of sin theta I will be 4 by 5, right? Yeah, it would be 4 by 5. It would be 4 by 5. Basically sin 53.13. You can do it from calculator, or in one of the video, I guess I have told you to remember few data, but you don't need to remember if you can't remember. But in JEE we used to remember this data, that sin 37 degree is 3 by 5 and sin 53 degree is 4 by 5. Correspondingly, cos 37 is 4 by 5 and then sin 37 is cos 53 would be 3 by 5. So those, if you can't remember, you have the calculator, you can do from the calculator as well. But in J we used to remember these data. Correspondingly, we can remember the data for tan as well. That's why I wrote it directly, that what will be my angle. Here also I wrote it directly without even using the calculator, because I remember it. If you cannot remember, then you can do it from the calculator as well. So it would be coming 4 by 5, because sine 53 degree I know it would be 4 by 5 only. And under root 2.5 sine theta t. So from here you can find the value of theta t, and that would come out to be 30.39 degree as far as I remember. Since this is from Sadiko only, so I am just copying the final answer. So this is the transmission angle we have got. Now we need to find reflected E field. So for that, what we need to do? We need to find the transmission coefficient. But this is your perpendicular polarization. So perpendicular 2 are cutting, neta of this, theta of this. So neta 2 cos theta I minus neta 1 cos theta t divided by neta 2 cos theta I minus neta 2 cos theta t. What I can take? I can take neta 2 outward. Neta 2 I will take outward. Neta 2 and neta 2 will get cancelled. What will be the ratio of neta 1 by neta 2? Neta 1 by neta 2 would be under root epsilon r2 divided by under root epsilon r1. What is under root epsilon r2? Under root 2.5 only, right? And under root of epsilon r1 is 1 only. So basically you just need to apply the formula and you just need to keep going. That's it, nothing else. So people like needlessly think that it is tough, but it is not tough. Cos theta I, what is theta I here? 53.13. 53.13 minus neta 1 by neta 2 is under root 2.5 and cos theta t is 30.39 degree, right? 30.39 only, 30.39, and then divided by cos 53.13 plus under root 2.5 cos 30.39 degree. You need to do this calculation. When you do this calculation, your answer will come out to be minus 0.389. This is the answer. This is the value of reflection coefficient. Okay. So from here, what are you understanding? Do you remember what was our assumption? Our assumption was that reflected electric field and incident electric field will be in the same direction. This was our assumption. But negative sign is coming. Negative sign is coming. So this was in plus ay cap. This was in plus ay cap. So certainly this would be in minus ay cap, because negative sign is coming. Because negative sign has come, that's why it has to be in minus ay cap. Okay. And will be multiplied with 0.389. So let's write down the expression for ER. So let's write down ERO. What will be your ERO? ERO will be 0.389 into 8. So what that is coming out to be? 3.112. So magnitude will be 3.112. Now very interesting thing will come. One more interesting thing will come. What is that? Cos omega t minus, what do you think what you will write down here? Here I know that it will be minus a by cap. What do you think what you will write down here? Here what do we write? K dot r, right? K dot r. Now we need to write, here we write K dot r. This is what we write here. But now what is my K vector? K vector has changed now. K is the reflection propagation constant. This was your incident propagation constant. This was your incident propagation constant. Why reflection propagation constant has changed? Look, beta value will not change because we are in medium, same medium only. So whatever the beta this guy is having, the same beta this guy is having. Beta value will not change. But the direction has changed, no? This was your incident, this is your reflected. So now your wave is propagating in this direction. That means actually it is propagating in minus z. It is propagating in minus z and plus x. That's why I always say whenever you solve this kind of problem on oblique incidence, always make the diagram. So this is how it came, plus z and plus x. But now this is how it is going. That means minus z plus x. Are you getting this point? So magnitude of ki, what was that? That was 5. Magnitude of ki was 5. That means that was our beta 1. So beta 1 and beta 2 both are equal. Magnitude is equal. but the direction has changed, no? Right? Direction has changed. So what I can write is that basically if I write down kr vector, so magnitude I know, magnitude will be 5 only. But now if I need to write down the direction, so how will I write down the direction? So for that I need to apply some mathematics. Okay. So how will I write down the direction? I will tell you a shortcut method as well. Do not worry about that. So this is my theta e only. This angle is theta e only. If this is theta e, this is theta e. So this will also be theta e. Now I am writing down only the direction. I am writing down only the direction. So for writing down the direction, what I will take? I will take vector as 1. So 1 cos theta e plus 1 sin 1 cos theta e minus az cap plus 1 sin theta i plus ax cap. Are you getting this point? 1 cos theta i, 1 cos theta i minus az cap, 1 sin theta i plus ax cap. So this is how I will write it down. Okay. So let's write down the direction now. So what is your cos theta i? Cos theta i is 3 by 5, right? Cos 53. Yeah. So minus 3 by 5 az cap, minus 3 by 5 az cap plus 4 by 5 ax cap. So minus 3 az cap plus 4 ax cap. Okay. And if I need to find k dot r, then minus 3z plus 4x. Okay. So what will be the answer here? 3.112 cos omega t minus 3z, that means plus 3z minus 4x minus ay cap. So this will be your reflected electric field. This is how I will get the expression. But in the examination, you do not need to do all these things. Okay. If you see it closely, what it was written, minus 4x minus 3z, minus 4x minus 3z. That means this is showing positive x and this is showing positive z. This is what they are showing, positive x and positive z. But I know that my reflected wave will be like this. That means this has to be in negative z and this has to be in positive z. Negative z and positive x, sorry, negative z and positive x. If this is how my wave is going, that means negative z and positive x. So my reflected wave will have negative z and positive x. So x sign will remain there as it is, but this sign will change. Basically from plus az to minus az you are going. So here you need to put plus and this minus will remain there as it is. Is that what we are getting? Yes. Plus 3z minus 4x. Are you getting this point? What did I do? I know that my beta will remain same. This magnitude will remain same. Just the change is in the direction. And angle is also same. This angle and this angle is also same. The only change that is there in the direction. Angle and everything, all magnitude, everything is same. Just the direction is different. So for that, what I can do, I do not need to calculate this unit vector again and again. What I will see that my incident wave was in plus z and plus x. Incident wave was in plus z and plus x. But reflected wave is in minus z and plus x. That means this sign would change. The sign of z would change and sign of x will remain there as it is. So whatever the ERO I get, this, what I mean to say is that this value I will be able to get, this direction I will be able to get, and if I need to change this, how will I change this? Using the direction. So first it was plus x plus z, now it is minus z plus x. So this sign would change, so this would be plus. That's it. So this is how I will be solving in the examination. Here just I gave you the concept that why this thing is happening, but in the examination and from further question onward, we will be solving in this manner only. Is that clear to you? Yes. Okay. And in the examination, like, you will have to pick an option. So even if you are comfortable with all these kind of things, that in which direction my wave is propagating, then you will be able to eradicate option very quickly. Okay, so I will solve some problem with respect to options as well. But in this problem, we are learning the complete concept. So since we are learning the complete concept, that's why we will see it completely. Okay. Now let's just say if you need to find HR, so how will I find HR? It is not asked, but still, if I need to find HR, how would I find? So what I would do? How would I find the direction of AHR? That would be AER cross, so not AER, sorry, it would be APR, direction of propagation cross direction of electric field, because what do I remember? P is equals to E cross H. So H is equals to P cross E. Is that clear to you? So what is your APR? APR is minus 3 by 5 AZ cap minus 3 by 5 AZ cap plus 4 by 5 AX cap cross minus AY cap. 3 by 5 y cross z would give you x. So this would give you minus x plus x cross y would give you minus z. So x cross y would give you z, but here there is minus sign. So minus 4 by 5 AZ cap. Can we solve using geometry? Can we get this direction using geometry? Certainly we can get it. So this is my electric field and this is my wave propagation. So where will be my incident magnetic field? I am talking about incident magnetic field. So E cross H. E cross H. So it should be downward, right? E cross H should give me P. So it should be here. This is my HI. This is my HI. And my ER is actually going inside. My ER is actually going inside. Here, this transmission coefficient, this coefficient became negative. So ER is actually going inside, right? So ER is actually going inside. So this is my inside. E cross H I need, right? So how would I do? E cross H should give me P. So this is my E cross H. So H would be in this direction. It would be in this direction. You can do it on your own. Basically, E cross H. E cross H should give you P. So this is my H. This is my HR. So if this is your HR, then you can see that it is going in minus Z and minus X. Basically, if this is your HR, so this is minus Z and minus X, right? So in the HR, you should have minus Z and minus X. This is what we are getting. Is that clear to you? Okay. So this is my direction of AHR. So if I need to write HR vector now, so how will I write? Reflected electric field. So 3.112 divided by 120 pi, right? Because neta of medium 1 is 120 only. This cos, this will not change. Cos omega t plus 3z minus 4x. 3z minus 4x. This will not change. But here that this is my direction. Minus 3 by 5 AX cap minus 4 by 5 AZ cap. You can solve it more. Basically, you can take this 5 outward and you can solve it more. Let's solve it more. Okay. No doubt about that. We can solve it more as well. So let's take the gate calculator and 3.112 divided by 377 then divided by 5. So what we are getting 1.6, 0.0016 we are getting. So 1.6 cos, and we can take minus sign outward as well. So minus 1.6 cos omega t minus 4x plus 3z. Then minus sign has been taken outward. 3ax plus 4az cap milliampere per meter. This option can be mentioned in your answer. Okay, in the examination, this option can be mentioned. It will not be mentioned like this. They will calculate the final value, and also they will take this 5 in action as well. They will take this 5 outward, then 3.112 divided by 125 divided by 5, then minus sign they have taken this outward. So minus 1.6 milliampere, because answer we were getting was 0.0016. Okay, so that would be minus 1.6 minus 1.65 I can write cos this guy and then this guy. Okay, so this is how the answer would be given. So you should be able to tell all whatever that can be asked in the examination. So reflected we have found, and reflected electric field and magnetic field we have found. Now we need to go to the transmitted part. So now some wave will be transmitted, right? Some wave will be transmitted, but it is being transmitted at a lesser angle. So this is how I will make. So wave is transmitted at 30.39 degree. 30.39 degree. Okay. Now, can you let me know what will be your KT? It will be same as KI. This KT, it will be same as KI. No, certainly not. Why is that so? Because here beta is also changed. Here you will have beta 2, right? Beta is also changed. Direction is also changed. Why direction has also changed? Because tilted angle is different. Here the angle was being tilted with 53 degree, but now it is being tilted with 30 degree. So angle has also changed. So everything has changed. So now I need to find KT. How will I find KT? KT is equals to mod of KT. that means beta, mode of KT, that means beta, and the direction. So both things I can find. So certainly I can find beta 2. How will I find beta 2? So what will be your beta 2? Beta 2 would be omega by C under root mu r epsilon r. What is omega by C? Omega by C is beta 1 only. So under root epsilon r2 actually. Epsilon r2. So beta 1 I am already having. What is that? Beta 1 is 5. So under root 2.5. 5 under root 2.5. 5 into under root 2.5. 2.5 under root into 5. 7.9. So beta 2 is 7.9. So this was important to find. Let's write down the unit as well. Radian per meter. Okay. So that's the unit. Radian per meter. Now let's see the direction. So for the direction, what we need to do? This and this. Right. This vector can be broken into two parts. So one is this 30.39 degree and one is this. This has a magnitude 1. Okay. So if I write down AKT, if I write down AKT, if I write down, so unit vector I have to assume cos 1 cos 30.39 AZ cap, right? You can see AZ cap 1 cos 30.39 AZ cap. If you have the patience and if you listen to me very carefully, then you will never get any question wrong from this particular topic. But if you don't have the patience, if you just want to learn within seconds, then you will never be able to solve problems from this particular topic. Okay. So now we are writing down AKT. So what that would be? Cos 30.39. 30.39 cos. So that is 0.862. 0.862 AZ cap plus sine 30.39. 0.5 EX cap. And what was the magnitude? Magnitude was 7.9. 7.9. So what will be your KT now? So into 7.9. So 4 AX cap we are getting. 4 AX cap plus 7.9 into 0.862. So 6.8, roughly around 6.8, right? Here also it would be written, yeah, roughly around 6.8 AZ cap we are getting. So this is my KT, okay? And if I do KT dot R, what that would be? 4x plus 6.8 Z. Now for reflected, what I need to find? Reflected magnetic field I need to find, transmitted. Transmitted electric field and transmitted magnetic field I need to find. So for that I need transmission coefficient. So what will be my transmission coefficient in case of perpendicular polarization? That is 1 plus gamma. So 1 minus 0.389. So that is 0.611. Okay. So now if I need to write down the expression of transmitted electric field, I am writing down the expression of transmitted electric field. Okay. What do you think? What will be the direction of transmitted electric field? That will be same as the incident one only. Because this is how the wave is going, this is how the wave is going. Electric field is directly coming from the plane. Like on this plane, there are infinite vectors. On this particular plane, there are infinite vectors. But this vector will always be perpendicular to all these vectors. So here, this is my reflected, this is my transmitted wave. This is my transmitted EM wave. So electric field is just perpendicular. That is coming towards me. Okay. And transmission coefficient is coming positive. That means it will be coming towards me only. Because what was our assumption? That incident, reflected and transmitted all will be coming towards you, or all will be going from the plane. Basically all will be in the same direction. Incident, reflected and transmitted all should be in the same direction. This was our assumption. Okay. And if tau is coming positive, which will always come positive only. Tau will always come positive only because it is 1 plus gamma. Even if this is negative, then it cannot be greater than 1. So it will always come positive only. Tau will always be positive. That means incident and reflected electric field will be same. But in case of perpendicular polarization, we will solve the problem of parallel polarization as well. There things will be different. Okay. So in case of perpendicular polarization, incident and transmitted electric field will always be same, will always be in the same direction. So direction I already know, that will be plus AY cap. What about the magnitude? Magnitude will be 0.611. 0.611 will be multiplied with 8. So 0.611 into 8. So that would be 4.88. 4.88 cos omega t minus kt dot r. So minus 4x minus 6.8 z ay cap. Is that clear? So this is what we are getting. Okay. Yeah. So this is what we are getting, and omega is the same only. Omega value you can find any way. So this is your ET. Now I need to find HT from it. If I need to find HT from it, then what I need to do? AHT is equals to APT cross AET. Okay. So do you know APT here? Yes. Do you know AET here? Yes. So both things we know. 4 AX cap plus 6. No, this is not my APT. My APT is 0.862 AZ cap plus 0.5 AX cap cross AY cap. Z cross Y would give me minus X. So minus 0.862 AX cap, and X cross Y would give me Z. Z cross Y would give me minus X, and X cross Y would give me Z. 0.5 AZ cap. Okay. So let's add another page. Okay. So now what will be my HTO? HTO will be equals to ETO divided by eta. 4.88 divided by eta 2. What is your eta 2? Eta 2 is 120 pi divided by under root epsilon r, which is 2.5. So eta 2 I need to find 2.5 under root reciprocal of that into 377. So that is coming out to be 238.43. 238.43. So 4.88 divided by 238.43. So if I take this reciprocal into 4.88, so that is coming out to be 20.4 milliampere per meter. So now I can write down the expression of HT. So that is 20.4 cos omega t. This guy will remain there as it is, minus 4x minus 6.8 z and then minus 0.862 minus 0.862 AX cap plus 0.5 AZ cap. Okay, so this is how the answer could be mentioned, or they can multiply 20.4 inside as well. Basically, how they can mention the answer, that they will multiply 20.4 inside. So 20.4 into 0.862. So 23.7 we are getting. 20.4. Is this magnitude correct? Let me check the calculation. Okay, let me check the calculation. Yeah, calculation is absolutely correct. So yeah, so it will come out to be, firstly this answer was in milliampere per meter. Okay, now they can take this 20.4 inside. So 20.4 into 0.862. So what that would be coming out to be 17.69 AX cap. And what about this? That would come out to be 10.37 AZ cap, and then cos omega t minus 4x minus 6.az. So in any way it can be mentioned in the examination, in the options, in any way the answer could be mentioned. You just need to solve it. Okay, so any of the answer you can get. Is that clear to you? Is that concept clear to you? Now this much big question will not come in your examination. Like, it will take a lot of time if this much big question is coming. We have taken 30 minutes to explain this question. But a lot of small questions can be framed, like they can ask the polarization, or they can ask the incident angle, they can ask the reflected electric field, they can ask the reflected magnetic field, they can ask the transmitted electric field, they can ask the transmitted magnetic field. So from this particular question only, there are 6 to 7 questions which can be framed. So in one problem we have seen a lot of concepts, and I hope you must have understood that if we make the diagram, everything will be crystal clear to us. Is that clear to you? So always make the diagram when such kind of question is coming. Now this question was asked in GATE examination, GATE 2023. 2023 I am saying, GATE 2013, sorry, not 2023. So this was asked in GATE 2013. Okay. And answer key was not released. Okay, I have tried finding the answer key, but I could not find answer key. Answer key was not released. So the answer of this question is correct, there is no doubt. But according to me, this should have been MTA. And till now, no educator I have seen that they will call it MTA. Till now, all the educators who have teach EMFT, I have seen their content. They are absolutely brilliant, but somewhere they are doing the mistake in this answer. Okay, they are saying the answer is 1, but this is also wrong. I will prove it. I will give the complete explanation as well why that is wrong. I will prove it using the boundary condition as well. So let's spend good enough time on this problem, but let's first solve the previous one. Okay, or let's first read the question. So incident wave is given. This is the transmitted one and this is the reflected one. Okay, these are the waves. A monochromatic plane wave of wavelength that is propagating in the direction as shown below. EI, ER and ET has been denoted as incident, reflected and transmitted electric field vector associated with the wave. So we need to find the angle of incidence and the expression of EI we need to find. So this expression of EI we need to find and angle of incidence we need to find. So angle of transmission is given, this is given. That what does that mean is that theta t is given, which is 19.2 degree. So what we can do, we can apply Snell's law. What Snell's law will say, that is sine theta I under root epsilon r1, under root epsilon r1 is 1 only. So that I am not writing. So sine theta I is equals to under root 4.5 sine theta t, which is 19.2. So what is the answer? Theta I, that would roughly come around 45 degree. Is that clear to you? So 45 degree. So these options are cut. This is how I will be solving in the examination. Now I am telling how I will be solving in the examination. So these two options are cut. Now what about the incident electric field? This is my incident electric field and this angle is 45 degree. So certainly, can I take a vector like this? This incident electric field will have a vector like this. If this angle is 45 degree, then what this angle will be? 90 minus 45. Why is that so? Because if I increase this angle will be 90, this will be 90 minus 45. That means it will be 45 only, and this angle will also be 45 degree. Okay. So if I write down the unit vector, if I write down the direction of AEI, what that would be? 1 cos 45, 1 cos 45 AX cap, 1 cos 45 AX cap plus 1 sin 45 minus AZ cap, because this is plus Z, this is plus Z. So upward direction is minus AZ cap. So minus AZ cap, right? Minus AZ cap. So what is answer? What answer is coming? AX cap minus AZ cap divided by under root 2. So electric field has this direction. So AX cap minus AZ cap divided by under root 2. So this option is correct. That's it. Okay. Or we can see more things. What we can see? We can see the value of beta. What we can see? We can see the value of beta. So what will be the value of beta? Beta 1 in this incident electric field. So this I am calling as medium 1 and this is medium 2. So what will be your beta 1? 2 pi by lambda, 2 pi by 6 into 10 to the power minus 4. So that would be pi by 3 into 10 to the power 4 radian per meter. So that is your beta. So here you can see pi by 3 into 10 to the power 4. Now what about this, sir, under root 2? How this under root 2 is coming? So that under root 2 is coming from the direction of a wave propagation. So what is the direction of wave propagation? How would you find? So this is how the wave is going. I need to find AKI. Okay. So I need to find this direction. So for that, I need to take this vector. Basically, if you can see the diagram clearly, I need to find this direction. So for that, I can take this vector and this vector. Are you getting this point? So 1 cos, this will also be 45 degree, this will also be 45 degree. So what will be the direction? What do you think? Plus x and plus z, right? So directly I am writing down the direction. You can write it on your own. So that would come out to be AX cap plus AZ cap divided by under root 2. So this under root 2 is coming from here. Now here I need to write down K dot R. So what will be my Ki dot R? So that would be X plus Z divided by under root 2. I hope you must have understood how did I write down this direction. So this is how my wave is going, no? So this and this, these two vector I am taking. So plus X and plus Z. Is that clear to you? So this is my K dot R. Now how would I write down the equation? So equation I would write down, incident electric field I need to write down. So that would be E naught e to the power minus j K dot R and then AEI cap. So what is my E naught? My E naught, where is my E naught? E naught is E naught only, sorry. E naught is E naught. What is the direction of wave propagation? Direction of wave propagation is AX cap minus AZ cap divided by under root 2. AX cap minus AZ cap divided by under root 2. K dot R. So what is the value of K dot R? So sorry, this is not my K dot R. For K dot R, you need to multiply with beta as well. That is pi by 3 into 10 to the power 4. For K dot R, you need to multiply with beta as well. So let's remove this one. So here I can write down my K dot R. Ki dot R. So here I just multiplied with AKI. Here I just did the dot product with AKI, but I need to multiply with beta as well. So pi by 3 into 10 to the power 4. In the examination, how you will be solving that I have told you directly by the option. But complete solution I am giving here. So pi by 3 into 10 to the power 4 and then x plus z by root 2. X plus z by under root 2. Right? So minus j. So pi into 10 to the power 4 x plus z divided by 3 under root 2. So this is my incident electric field. Is that correct? Yes. So this is the complete answer. But in the examination, you would be clicking on the option. Now try solving it on your own. I am telling as per me, no option is correct. According to me, no option is correct. So try solving it on your own. Okay. And then let me know your answer. So let's start the solution now. I hope you must have attempted it on your own. So what all things I will remove? Let's remove all these things. We have used it. Okay. This is plus z only, that I already know. What I need to find? I need to find the reflected electric field. Okay. So for that we need transmission coefficient. What was the formula of transmission coefficient? The formula for transmission coefficient, which kind of polarization is that? Parallel polarization, right? Because electric field is in the plane of incidence. So this is parallel polarization. Parallel polarization. What is the other name? P-polarization, right? So what was the formula of transmission coefficient? Neta 2 cos theta t minus neta 1 cos theta I divided by neta 2 cos theta t plus neta 1 cos theta I. What was the assumption? What was the assumption made for deriving this formula? There was some assumption. Do you remember this thing? In case of perpendicular polarization, what was the assumption? In case of perpendicular polarization, the assumption was that incident, reflected and transmitted electric field are in the same direction. But in case of parallel polarization, what did I say? What is the assumption? The assumption is incident and reflected magnetic field are in the opposite direction. When we were studying parallel polarization, should I get back to the slides? Yes, I should get back to the slides. So when we were studying parallel polarization, this was our parallel polarization. So what was the assumption? That incident and reflected magnetic field are in the opposite direction. This was the assumption we made. If this is towards me, then this is going into the screen. But is it happening in this diagram? Because they have given the diagram from their own side. These guys have given the diagram from their own side. So let's check, is it happening in this diagram? So this is E and this is the direction of propagation. So E cross H. So H is coming outward. So this is the direction of H. And this is E. E cross H. H is coming outward. So here what is the scene? That AHI and AHR is equal here. But according to our assumption, AHI should be minus equals to AHR. Here what I am saying is that here AHI should be equals to minus, here AHI is equals to AHR according to diagram, according to diagram given. But the formula that we have derived, which was gamma parallel neta 2 cos theta t minus neta 1 cos theta I divided by neta 2 cos theta t plus neta 1 cos theta I, that was corresponding to the condition that your AHI should be equals to minus AHR. This was the assumption made for deriving this formula. So now if my gamma value comes negative, then let me know one thing, whether the given direction of electric field is correct or incorrect. Basically, if my gamma is coming negative, what is my question? Think about it. Okay, what is my question? If my gamma is coming negative, that means this direction would be correct, or I should take opposite direction of reflected electric field. You let me know this answer. Okay, call aa raha hai. Did you understand my question? If gamma is negative, then reflected electric field will be in this direction, or I need to take the opposite one, What do you think? It will be in this direction only. Why is that so? Because the formula that we have derived, that was having opposite condition. Are you getting this point? Now I know the value of gamma perpendicular, that will come out to be minus 0.23. Okay, this gamma parallel will come out to be minus 0.23. That means gamma parallel for electric field is coming out to be minus 0.23. If it was positive, that means this direction would have been interchanged. Why is that so? Because how we derived the formula? We derived the formula like this. Has it gone? We derived the formula like this. So for this condition, here you can see incident and reflected. For this condition, if my gamma was coming positive, then this diagram was correct. But if my gamma is coming negative, then this electric field has to change its direction. Are you getting this point? Right? But here, since we have interchanged the condition, that incident and reflected magnetic field are in the same direction now. So if gamma becomes negative, that means direction is correct. If gamma becomes negative, that means shown direction is correct. And if it becomes positive, then we need to take the opposite direction. Are you able to think it? Like, it is a very simple point, not very complex. I think you should be able to think it. What I usually say is that if gamma is positive, that means the direction would be same, and if gamma is negative, then direction should be interchanged. But in this case, this diagram is shown not as per the derivation. As per the derivation, AHI should be equals to minus AHR. So this diagram is not shown according to the derivation. So that's why we need to take the opposite thing. That means if gamma is becoming negative, that means the direction shown is correct. And if gamma is becoming positive, that means direction shown is incorrect. We need to take the opposite direction. Is that clicking to you or not? Okay, it should click, right? So now we need to find the value of gamma parallel. So incident angle, reflected angle, everything we have. Neta 2 value we have, neta 1 value we have, right? Neta 2, neta 1 value. Do we have neta 2 and neta 1 value? No, neta 1 will be 120 pi, neta 2 will be what? Here I can find value of neta 1. Neta 1 will be 120 pi and neta 2 will be 120 pi divided by under root 4.5. Okay. So if you put these values here, what you are going to get? Gamma parallel E, that is minus 0.23. Okay. And what does it show? That shown direction in the diagram is correct. So this direction is correct, whatever the direction they have shown. That means electric field will be going in negative x. Electric field will be going in negative x and negative z. Are you getting this point? Let's see it again. Electric field will be going in negative x and negative z. So in the answer, the direction should be minus ax minus az, but there is no such direction. Only this direction is there, minus ax and minus az, but the reflection coefficient is not correct here. Are you getting this point? In the answer, your direction should be minus ax and minus az, because electric field is going in minus ax and minus az. So in the answer, this minus sign should be there. Okay. So answer would be this minus sign should be there. Very, very important. So reflection coefficient is 0.23. So basically you will multiply 0.23 to this guy. Okay. You will multiply 0.23 to this guy, but minus sign also you will put. You are not going to copy the direction. You will never copy the direction. You can only talk about the amplitude. What is the amplitude? E naught is the amplitude. So what will be my, basically, what is my amplitude? What will be my ERO? ERO will be equals to 0.23 into EIU. I am only talking about the magnitude. So that would be 0.23 E naught. Okay. What about the direction? The direction is 45 degree. This angle is 45 degree. This angle is 45 degree. This angle is 45 degree. So 1 cos 45 minus ax cap and 1 sin 45 minus az cap. So direction would be minus ax cap minus az cap divided by under root 2. Okay. So my reflected electric field will be equals to 0.23 ax cap plus az cap divided by under root 2. E to the power, it is written in e to the power, okay, e to the power minus j. Beta value will remain same, but what about the reflected EM wave direction? Beta value will remain same only. Beta value will remain same only. Now let's talk about the reflected EM wave direction. So reflected EM wave will have plus x and minus z. This is my k. So plus x and minus z. So plus x and minus z. So e to the power minus j k dot r. So what is the value of beta? So basically here what will have pi by 3 into 10 to the power 4. In this case x plus z was coming. In this case x plus z was coming because the direction was in case of incident thing. So this was your plus x and plus z. That's why x plus z was coming. X plus z was coming. Now what is the scene? Now the scene is x minus z. So x minus z would come. So what is x minus z? X minus z, you can see here x minus z. X minus z would come. Okay. So answer would be, what would be the answer? Pi by 3 under root 2 into 10 to the power 4. So plus x and minus z. X minus z. So that would be the answer. Are you able to understand this point, that how I am saying that negative sign would come? This thing you could have done it on your own because we have studied it. What did I say? Beta value is not changing. If beta value is not changing, that means certainly you just need to see the direction. So initially your incident EM wave was having plus x and plus z. Now your reflected EM wave is having plus x and minus z. So initially x plus z was coming. Now x minus z would come. X minus z would come. There is no doubt about that. All these things, beta value, all these things you will be able to write down. But what about this? What about the direction of electric field? So for the direction of electric field, what did we show is that we can write down this formula, but this formula has come by an assumption. What is that assumption? That incident and reflected magnetic field should be in the opposite direction. But here they are in the same direction. That means if my gamma is becoming negative, that means the shown direction is correct. And if your gamma becomes positive, that means shown direction would be incorrect. Is that clear to you? Okay, let's solve this question using the boundary condition. What I am saying, solving using the boundary condition. Okay. So same diagram I have copied, because you might not be satisfied with my explanation, but let's solve it using the boundary condition. If I solve it using boundary condition, then you will be satisfied, right? So solving using boundary condition. So this is my boundary, right? This is my boundary. This is your boundary. Because wave is coming like this and it is being reflected. So this has to be boundary. So if this is my boundary, so I need to find the component along the boundary. So this would be the component along the boundary, tangential component, and this would be the component along the boundary. So the angle would be 45 degree. This angle will also be 45 degree. So can I write down in this manner that EIO cos 45, that is under root 2, minus ERO, because the direction are opposite, minus ERO divided by under root 2. And what will be the component of transmitted one? This will be the component of transmitted one, right? So this angle is 9. Basically, I need to find, now I need to find which angle? I need to find this angle now. I need to find this angle. So how will I find that? So if this is theta, this is also theta, this is 90 minus theta, so this will be again theta. Are you getting this point? This angle is theta, this angle is theta, so this angle is also theta. If this angle is theta, then this angle is also theta. So this angle is also theta. This angle is 90 minus theta, so again this angle will be theta only. So that angle is 19.2 only. So what I am getting is equals to ETO cos 19.2. Okay, I have written down the values because I have solved it. So where has that notebook gone? This is the notebook. So what is the answer we are getting? Okay, so second, let's first, this was the condition, then let's apply the second condition, or I have written down the answer. So the, if I solve this equation, what do I get? EIO minus ERO is equals to 1.33 ETO. This is what I am getting. So this is my equation 1. I have to add a page. Okay, another page is there. So EIO minus ERO I have given. Now other, what we can apply? We can apply the magnetic boundary condition. But magnetic field we know all are coming outward. This is also coming outward only. You can see E cross H should give me P. This is also coming outward only. E cross H should give me P. And this will also come outward only. So all magnetic fields are coming outward only. All are coming outward. So what I will write? HIO plus HRO is equals to HTO. HIO plus HRO is equals to HTO. That means EIO plus ERO divided by eta 1 is equals to ETO divided by eta 2. Okay. So EIO plus ERO. What will be the ratio of eta 1 by eta 2? Eta 1 by eta 2 would be under root 4.5. Right? Because eta is inversely proportional of under root epsilon r. So eta 1 by eta 2 would be under root epsilon r2 divided by under root epsilon r1 is equals to ETO. So what we are getting? This is 2.12. So EIO plus ERO is equals to 2.12 ETO. So this was equation 2, and what was our equation 1? EIO minus ERO is equals to 1.33 ETO. And if I add both of them, what I am gonna get? EIO is equals to 2 EIO is equals to 3.45 ETO. So from there ETO is equals to coming out to be, this is just the calculation, this calculation you can do on your own, 0.58 EIO. Then I can put this value in equation 1, right? Where I can put in equation 1 I can put. So EIO using equation 1. EIO plus ERO is equals to 2.12 into 0.58 EIO. So what that will give me? 1.23 EIO. Okay. So EIO by ERO. What that is coming out to be? 0.23. So basically you just need to multiply by 0.23, nothing else you need to do. You just need to multiply by 0.23 and the direction shown as correct only. Whatever the direction of electric field they have shown, that is correct only. But what teachers have done, or what students think, they would think that sir, gamma is becoming negative. Sir, gamma is becoming negative. So what I would do is that I will take the opposite direction. But blindly you should not take the opposite direction. You should always understand that what was the assumption you made when you were deriving. That's why I was focusing so much on the assumption, that when I was deriving the equations, so what was the assumption I am making? So this diagram is not made as per your assumption. Are you getting this point? This diagram is made opposite. This is opposite to your assumption. Okay, and we have proved it using boundary condition as well. Forget about formula. No formula we applied here. Here we simply got to know that your ERO is just 0.23 times what I have done here. ERO divided by EIO. Sorry, ERO divided by ERO. So your ERO is just 0.23 times of EIO. There is no change in the direction shown. So whatever the direction has been shown, that is absolutely correct. So you do not need to change it. So what student have done is that they saw gamma equals to negative, then they interchange the direction, and once they interchange the direction, then what they are going to get? Plus x and plus z, and then this answer will be matched. Plus x and plus z. What I am saying, if they interchange the direction, then what they will see, that electric field is going in plus x and plus z, and this answer would be matched. I guess IITs did the same mistake. Okay, they also did the same mistake. They did not even see that how they are making the diagram, and here we are proving it using the boundary condition. So I don't know why till this date this question have never been challenged. What I feel is that I am absolutely correct, but if I have something wrong, and if some teacher is watching this video, then certainly they can get in touch with me. Okay, they can certainly message me on Telegram or anywhere. We can discuss about it. Now I'm not taking it on ego or anything, but this is what I feel, because till now I have seen like every resource whoever teach EMFT, like there are legendary teachers. Okay, but the thing is I do not find it correctly there. Is that clear to you? Okay, so yeah, this was the answer, this was the explanation. Let me repeat it again, whatever that we have studied in this question. So first we saw the incident and reflected and transmitted EM wave was given, but we got to know that it is parallel polarization, so we wrote down the formula of our transmission coefficient. First we needed to find EI, that was pretty easy for us to find, that we found out. We saw the direction of electric field, and with respect to that we made our EI as well. Now for reflected electric field, if this is my incident electric field, so for reflected electric field I need to write down my reflection coefficient. So that reflection coefficient, which I remember the formula that I remember, that was made with the assumption that incident magnetic field and reflected magnetic field should be in the opposite direction, but since they are in the same direction here, so that's why if my gamma is negative, that means given diagram is correct. If my gamma is negative, that means given diagram is correct, but if my gamma comes out to be positive, that means reflected electric field will oppose its direction. That means if this is the reflected electric field, then actual direction would be this. It would be opposite. But then we go to know that our gamma is becoming negative only. That means the shown diagram is correct. If the shown diagram is correct, then certainly our direction will have a negative sign. So a very important point, that this negative sign would be there. Is that clear to you? I hope you enjoyed this analysis. I hope you enjoyed this particular concept as well. Let's move to our next question. So this was asked in GATE examination. This was M.tech. Like you see this concept, no? Oblique incidence. Even IITs are doing mistake in framing the option. Although this was not noticed. What happened was, in this question what happened? Actually they asked this question. So everyone got this 0.23, and just as they saw 0.23, this is correct. They just saw the reflection coefficient. Reflection coefficient is coming out to be 0.23. They forgot about the sign and all these things. So they just saw that 0.23, and this was correct, and nobody challenged it. And answer key was also not released. I don't know whether it was given by given MTA from IITs or I'm not sure, but 0.23 just as they got, they mark it correct. Okay, but that was not correct. Minus sign has to be there, right? Now let's see this question. A plane wave is propagating in air with electric field is incident on a perfect conducting slab positioned at x less than 0. You need to find the E field of reflected wave. You can try it on your own. Okay, this was given MTA because none of the options were matching. So I have given option E as well. Now you know the answer. This would be the answer. You already know it. But try it on your own. How would you think in the examination? How would you think? First thing is, if I see the question of EM wave and whether it is normal incidence or whether it is oblique incidence, I will always make the diagram. Okay. So first I will tell you the correct solution. Then I would tell you how I would have thought in the examination as a student. As a student, how I would have thought. That I will tell you later on. But initially, I will tell you the correct solution, that how we should solve it. Okay. So what they are saying is incident on a perfect conducting slab positioned at x less than 0. So first you see what is my direction of wave propagation. Direction of wave propagation is minus 3x plus 4y, because we need to take minus sign outward. So minus 3x plus 4y. So minus 3ax plus 4ay. And boundary is x equals to 0. So how will I make the diagram? This is how I will make the diagram. XY plane I need to make. This will be my X, this will be my Y. So how my wave is propagating? -3. Basically my wave is propagating -3 and +4. So wave is propagating like this. Wave is propagating like this. It is incident on some angle. This is perfect conductor. Perfect conductor. So for perfect conductor, what is the value of eta? 0, right? For perfect conductor, eta value is 0 or eta 2 I can write. So there will be no transmission. Like in a conductor, there can be no electric field, there will be no magnetic field, there will be no EM wave. So in the conductor, in the perfect conductor, there will be no EM wave. So all part will be reflected back. Is that clear to you? This we have already seen in normal incidence. In conductor, there will be no electric field, no magnetic field, nothing. All part will be reflected back. Is that clear? Okay. So minus 3x 4ay. Now let's make the electric field. Let's make the electric field. So electric field is in plus x plus y and plus z. Where will be z? X cross y should give me z. So this will be your z. This will be your z. So plus x plus y and plus z. This will be your electric field. There are three components of electric field. So in the x 8, here 6 and here 5. Now in the reflected electric field, what will be the direction that we don't know? That electric field will be like this or it will be like this. How it will be, that we don't know. So how this question should be solved? We will apply boundary conditions. Okay, what we can apply? 5 AZ cap. 5 AZ cap is coming and there is no electric field here. There is no electric field here. So can I apply the boundary condition? How will I apply the boundary condition? So I am applying boundary condition. Applying boundary condition. Later on I will tell you how we will solve in the examination as well. How I would have thought. Okay. So applying boundary condition. Because I have given enough thought process, so you could have thought it without even boundary condition. Because like boundary condition will come lastly. In the last you will think of boundary condition. First you will think of the formula that you have studied. So that explanation I will give you, but first let's solve it using boundary condition. So first what I am assuming is that my reflected electric field is E1 AX cap, this is reflected electric field, plus E2 AY cap plus E3 AZ cap. This is what I am assuming. Okay, E1 AX cap plus E2 AY cap plus E3 AZ cap. This is what I am. Yeah, sorry for the interruption. So what I was saying, we are applying boundary condition and we have assumed our reflected electric field. So what we have assumed that in the reflected electric field, we are having E1 in X direction. What we have assumed, E1 AX cap plus E2 AY cap plus E3 AZ cap. So E1 in X direction, E2 in Y direction and E3 in Z direction. This is what we have assumed. E1, E2 and E3. Now can I apply the boundary condition? Yes. This is my boundary. What all are my tangential component? E2 and 6. Along this boundary, my tangential component are E2, 6. Right? So first boundary condition I can apply is along this side of boundary, E2 plus 6 is equals to 0. Why is equals to 0? Because along this side of boundary there is nothing. E2 plus 6, this is my tangential component. So E2 plus 6 is equals to 0 because here there is no electric field component. So from here value of E2 is coming out to be minus 6. Okay. What else I can apply? There is another component which is tangential to the boundary. So this is my boundary. So one component was this. Another component would be this as well. No? This Z component is also tangential. Are you able to understand this point? This X component is perpendicular to this boundary. This X component is perpendicular, but Z component is also tangential. So 5 plus E3 is equals to 0. So this is one I am getting, and E3 plus 5 is equals to 0. So E3 is coming out to be minus 5. So two things I have got. Now next what you would think that sir I will apply the boundary condition, but I will apply it for normal component. So what I am gonna do sir, I am gonna do D1n is equals to D2n. That I am gonna do. That electric flux density of this side is equal to electric flux density of that side. But for that you would require epsilon value, right? Because D is epsilon E. So you would require the value of epsilon. This is your free space. This is your air. So epsilon value will be epsilon naught only. But do you know the epsilon value of this guy? No. So we are not going to apply the perpendicular boundary condition that D1n is equal to D2n because we don't have epsilon data. So that we cannot apply. What else can you think? What do you think? What do you think? What else can you think? What do we know? For EM wave, the direction of propagation and electric field are perpendicular to each other. This is always true that E, K and H will be perpendicular to each other, right? So what do we know is that my KR, reflected direction of propagation, will be perpendicular to my reflected electric field for EM wave. Is there any doubt about that? No doubt about that. So what will be my KR? Can you let me know what will be my KR? So beta value will not change. What is your KI? KI is minus 3x plus 4ay. So beta value will not change. So basically these guys will not change. 3 and 4 will not change. Just you need to take care of the direction. Here what was the direction? Direction was minus x and plus y. The direction was minus x and plus y. But now the wave is reflected like this. So it will have two direction. Which all two direction it will have? Plus x and plus y. The direction would be plus x and plus y. For incident one, the direction was minus x and plus y. So minus and plus. Now the direction is plus x and plus y. So can you write down KR? That would be 3ax plus 4ay. This would be my KR. 3ax plus 4ay. So what is my KR? What I can write down? That my KR dot ER is equals to what? 0. Because they are perpendicular to each other. So dot product would be 0. So what is my KR? My KR is 3ax plus 4ay dot ER. What is that? E1 ax cap plus E2 ay cap plus E3 az cap. And that is equals to 0. So what you are getting? 3E1 plus 4E2 is equals to 0. 3E1 plus 4E2 is equals to 0. So what is your E2? E2 is minus 6. So from here E1 value you are getting is 8. So E1 value you have got 8. Okay. So what is your reflected electric field? Reflected electric field is basically only I have written down x, y, z component. This I did not write. E to the power minus j, e to the power j omega t. This you can write down on your own. How will you be able to write down? What I will write down? Now my reflected electric field. So this was not correct actually. I should have written e to the power minus j k dot r as well. Right? E to the power minus j k dot r as well I would have written. So 8 ax cap minus 6 ay cap minus 5 az cap a to the power minus j k dot r. What is my k? What is my kr? Kr dot r basically. What is my kr? My kr is 3ax plus 4ay. So that would be 3x plus 4y. So that would be the answer. So omega t will also be there. So into j omega t. Okay. So j omega t will also be there if I need to introduce the time term. So if I solve it completely, what I'm gonna get? My ER would be 8ax minus 6ay minus 5az e to the power j omega t minus 3x minus 4y. So this would have been the answer, which was not mentioned in the option. Okay, so that was a blunder from IITs. Like this kind of error should not happen from them. Okay, these kind of errors should not happen. At least like some guy would have thought of it and he would have done this analysis. He would feel very good that now I have got the answer. Then he would see the options that no one is matching. So it would be very demotivating for him. So this is the correct answer. So this is how we got it. Okay, this was given MTA, but in the examination, if I had been the student, I would feel very low that I solved all this. Still, some answer is not matching. So I am doing some mistake. This is what I would be thinking in the examination. Okay, yeah. So forget about it. Now boundary condition is our last option, right? Always boundary condition is our last option because Here also we saw that we solved it using the formula, then we applied the boundary condition just to verify it. So in the last, if you do not think anything, if you are not able to solve any problem, just apply the boundary condition. But it will not click so early to you. I know that. I know this thing, that you will not be going towards boundary condition so early. You will be going towards formula. That I know. So let's try solving it using the formula. So I will just copy the diagram, and now I will tell you how I would have thought in the examination. Just I am telling thought process of examination. Okay. Thought process in examination. Because I have given enough intuition in this particular chapter, so I hope you will be able to think in the manner that I would have thought, or I would have taught, because now I am teaching and now I am not a student. So first I would have made this diagram. Let's make it more clear. First I would have made this diagram. Forget about this x equals to 0. This is the boundary that I know. This is the perfect conductor. Then I would know that here in the z direction I am having 5 and 6 in y and 8 in x. So in z direction I am having 5. This is one of my electric field, and this is my other electric field. How I am writing? Plus y and plus x. So my other electric field will be this. Now this electric field is the case of parallel polarization. This electric field is the case of parallel polarization, and this electric field is the case of perpendicular polarization. Perpendicular polarization. Now I remember the formula for both parallel polarization and perpendicular polarization. What are those formula? Neta 2 cos theta t minus neta 1 cos theta I divided by neta 2 cos theta t plus neta 1 cos theta I. Then I will just copy this formula. For 2 as well, I remember the formula. That would be neta 2 cos theta I cos theta t cos theta I cos theta t. Neta 2 cos theta I, neta 2 cos theta t cos theta I cos theta t. And I know that neta will be equals to 0. So this will come out to be minus 1 only, and this will also come out to be minus 1. Yeah, so my gamma and tau will come minus 1. Now I will solve with respect to the parallel component of electric field. What I am saying, this is my incident electric field, but this is the parallel component, right? There are two kind of polarization here. Parallel polarization is also there, perpendicular polarization is also there. Both polarization are there. So first I am solving with respect to the parallel polarization. Now while deriving the parallel polarization expression, while deriving this formula for electric field, what assumption we made? The assumption we made was that incident magnetic field and reflected magnetic field should be in the opposite direction. The assumption was incident and reflected magnetic field should be in the opposite direction. So with respect to this parallel component, where will be my magnetic field? E cross H should give me P. So with respect to this parallel component, my magnetic field will be here. This is my incident magnetic field. But with respect to only parallel component, okay, only parallel component. Now my gamma E is becoming negative. That means the assumption that I made, that if this is cross, then this should be dot. If this is going downward, then it should be coming towards you. This was the assumption. But that was for gamma equals to positive. If gamma electrically is becoming negative, that means our assumption will be opposite. So if it is going downward, then certainly this will also be going downward only. Are you getting this point? While deriving this gamma, the assumption made was that incident and reflected magnetic field should be in the opposite direction. But here I am getting to know that by using this formula, I am getting gamma is equals to minus 1. If gamma E is equals to minus 1, that means gamma H is equals to plus 1. Gamma H is equals to plus 1. That means H is not changing its direction. H is in the same direction only. So H is going down only. And now this is the direction of wave propagation, and H is going down. This is the direction of wave propagation, and H is going down. Okay. So E cross H I need to do. So where will be my E? E cross H. So E will be in this direction. So my reflected electric field, this is my reflected electric field, but with respect to parallel component only. With respect to parallel component. Are you getting this point? With respect to parallel component, I am having this reflected electric field. Is that clear to you or not? Certainly it is clear. Now with respect to the perpendicular component, what will be my reflected electric field? What do you think? With respect to the perpendicular component, because what is your, why I am writing tau? Really sorry, this was a blunder from my side. This was the gamma perpendicular only. This was gamma perpendicular. So my gamma perpendicular E is -1. And what was the assumption? The assumption was that incident, reflected and transmitted, all electric field should be in the same direction. The assumption was incident, reflected and transmitted electric field all should be in the same direction. But since gamma E is becoming negative, that means this is my incident. So reflected electric field will be in the opposite direction. So this will be my reflected electric field with respect to the parallel component. Are you able to understand this point or not? So this we were talking about EI perpendicular. So with respect to the perpendicular component also, we are getting our reflection coefficient equals to -1. That means reflected electric field has to be opposite, because the assumption that we made was that incident and reflected electric field are in the same direction. But once we derived the formula of transmission coefficient, reflection coefficient, we got to know that it is -1. That means incident and reflected electric field has to be in opposite direction. Is that clear to you? So now you can see this will be in minus AZ. What this will be? This will, you see the direction, plus AX and minus AY. So from here what you are getting to know, minus AX and plus AY. I am not sure about the amplitude. What will be the amplitude? Whether it will be like, you are sure about the amplitude as well, because the reflection coefficient is 1 only. So amplitude will be same. Basically this 8, 6 and 5, they will be same only. 8, 6 and 5, they will be same. But unit vector, minus AZ cap, minus AX cap and minus AY cap. So what you are understanding here, this is minus AZ, okay, and plus AX, this is plus AX and minus AY, So what you are understanding, that 8AX in the X direction you are having, amplitude will be same, 8, 6 and 5, they will be same, just the direction has changed now, minus 6 AY and minus 5 AZ. This is how I could have thought using the formula as well, without even applying the boundary condition. Did you understand this point or not? Without even applying the boundary condition, using the concept of parallel and perpendicular polarization, how you would have solved it? Is this clear to you or not? Right? This is clear. I hope you enjoyed this analysis. I hope you like, everyone will teach you this analysis, like wherever you see the solution, you will see this analysis. But how you would have thought using formula? This is something requires a lot of effort, and I hope you enjoyed this analysis, and I hope you would like this video and share it with your friends, that what kind of depth has been taught on this channel. Okay, so do share it with your friends and let them know that what kind of depth has been covered and what kind of misconception has been cleared. So shall I repeat this particular analysis again? So what was the analysis? I saw the electric field component. There was parallel polarization as well, there was perpendicular polarization as well. I remember the formula, but I remember the assumption as well. What was the assumption for parallel polarization? That magnetic, incident magnetic field and reflected magnetic field will be in the opposite direction. But since gamma is becoming negative, that means incident and reflected magnetic field will be in the same direction. So if I know the direction of incident and reflected magnetic field, then certainly I can mark the reflected electric field as well. So this was my incident electric field and this was my incident magnetic field. So E cross H, this was the direction. Now if I go towards the reflected part, so reflected magnetic field will also be going into the plane. So that is going into the plane. So E cross H should give me P. So E will be coming this side only. So E is plus X and minus Y. E is plus X and minus Y. So plus AX cap minus AY cap. Is that clear to you? Till this point it is clear. Now what about perpendicular polarization? So again it is becoming negative. That means assumption that we made, that was incorrect. Basically the assumption we made that my EI and ER should be in the same direction, but they will be in the opposite. So EI is coming towards you, so ER should be going in. So minus AZ gap would come. And since this is 1, so magnitude will not change. Since this is 1, magnitude will not change. So 8 AX cap minus 6 AY cap minus 5 AZ cap. And that's it. This is how you would have marked the correct option. Then you can certainly write down KR vector, and with the help of KR vector you can certainly write down this term as well. That is not tough to write down. Is that clear to you? So I hope you enjoyed every single analysis of this particular video. I hope I have made this particular topic, which is very tough, Like people will not even teach these questions. Let me tell you, okay? Like teachers they try to avoid this concept, but we have spent enough time, like roughly around 4 hours we have spent. One video was the previous one where we spent 110 minutes. I'm not sure how much time we have spent for this particular video because there has been cut in between, because I told you this is a wedding season, so I need to go somewhere in between. So there has been cut, but I hope I have given enough analysis and your concentration was also not broken. This is what I hope, and I hope you enjoyed this analysis. If you enjoyed it, do comment down. Okay, yeah. So now in the next video we can see assignment, but along with that there is one small topic left, which is polarization. So polarization also we need to cover. EM wave polarization, very simple topic. Yeah, and when we are studying that Maxwell equation, there also I gave you the intuition behind that. What was that? E to the power j theta. E to the power j theta, if you see, sine wave was running, cos wave was running, and it was being circular on imaginary and real plane. So that kind of analysis we have to do for EM wave as well. So there I will give you visualization. So that we need to study, and then we can see the assignment. So let's see, we can see the assignment first as well. So let's see what the next video will be about, whether it will be about wave polarization or whether it will be about or assignment. So most of the topics we have already covered for EM wave, right? So yeah, let's meet in the next video. Thank you very much.